It is quite difficult because I would like to see more of the CSSD managers being involved in that discussion, which I don't see much, I have to say, in Europe. It's more of the industry trying to drive this limit down for probably very good reasons, although we cannot really justify it scientifically speaking, which may, on the side of CSSD managers, make it hard to accept that they would have to invest more time and money to make sure there is less and less protein, where the limit may not be as clear as it's set in the guidelines.
Millions of patients undergo surgical procedures every single day. Working behind the scenes are the technicians who go largely unknown, even to the patients whose lives are so dramatically impacted by their work. This is Beyond Clean, the global voice of sterile processing. Join us as we explore this hidden world and introduce you to the unsung heroes driving the advancement of our profession. And now, your hosts, Hank Balch, Justin Poulin, and Michael Matthews. Beyond Clean.
This week on Beyond Clean, we speak with Dr. Thomas Vanzieleghem, Scientific Director at OneLIFE. Dr. Vanzieleghem conducted his PhD thesis in the field of microbiology and more specifically on biofilms. His work at OneLIFE, based in Belgium, involves manufacturing enzymatic detergents for the reprocessing of medical devices such as surgical and dental instruments and endoscopes. There, they focus on developing solutions to detect and treat biofilms that contaminate the healthcare environment, including medical devices, to eliminate persistent reservoirs of pathogens causing healthcare-associated infections in an effort to help SPD and CSSD professionals improve the quality of reprocessing medical devices. So this is something I'd say we've covered in previous episodes, but enhanced visual inspection and other detection methods is really important. And I know last week we spoke to Pavel de Sternberg-Stoyalovsky, and really these two interviews bump right up against each other, Hank.
Yeah, Justin, anytime that we get the opportunity to talk about new technology, I get very excited because I know these are the kinds of things that really take us from the old way of sterile processing into the next generation of sterile processing. If you give technicians the tools they need to inspect more efficiently, to see down to that microscopic level, oh man, it's amazing how safer our processes can become. So I'm very excited to talk to Thomas today about the whole scope of protein detection, why it matters, as importantly, the new things that are going on in the industry to make this technology available to frontline users.
Beyond Clean. Joining us now is Dr. Thomas Vanzieleghem, Scientific Director at OneLIFE. And Thomas, we brought you on the show today to talk about protein detection technology. I wanted to thank you for, I know it's a different time in your part of the world. I wanted to thank you for making time to come on the show today.
Thank you for having me. It's a pleasure to be on the show. To be honest, I'm a fan of listening to the different podcasts, so I hope I will be able to bring valuable content to the listener today.
Excellent. Well, we've been looking forward to this interview as well because protein detection is becoming more and more of great interest of our listening audience, and I think it's technology that needs to continue to advance. So why don't we tell everybody what protein detection is, how it's viewed differently around the world in CSSD and sterile processing departments?
Protein detection, CSSD, is kind of a way for you to make sure that your instruments that are going through your CSSD are actually clean before they go into the sterilizer, because you will have the cleaning process and you have to make sure that your instrument is clean, at a deep microscopic level before you put it in the sterilizer, because sterilizer will, of course, kill all the microorganisms, but it will not clean your instruments. So protein detection is really a way to not rely solely on your eyes to kind of visually see if there was residues of proteins or other soils on the instruments when it's going out of the washer, but use a tool that's much more sensitive and then highlight the contamination that your eyes are not able to see. So I think it's very valuable, insights for CSSD managers and quality managers in CSSD just to verify the cleanness of the instruments in general, all these instruments that before they are released for sterilization. Of course, the patients thereafter are processed with the cleanest instrument possible. And in terms of around the world, I think, this topic really started in Europe with different views, really, because in the UK, for example, they've been really tough on increasing that guidelines to very low level of detectable proteins on one instruments. And in EU mainland, they kind of started to look at how proteins can be measured per unit of surface. So to be clear, the UK would visualize the instruments on its whole, like you would have to detect proteins on whole of the instruments. And in the Germany, let's say Germany is driving this, then you would be detecting per unit of surface, so a centimeter square, you would detect the proteins and then make a general calculation for what's red protein residue is on the instruments in total. And so these two different, let's say, approaches are still fighting each other because there is a lot of different theories behind it. And let's say in the UK, you tolerate a very low amount of these proteins, whereas in the UK and the EU mainland, you would tolerate very high amounts of proteins if the instrument is large. Because let's say you have an instrument that's about 10 centimeters square, then let's say you tolerate 6 microgram per centimeter square, you would have an amount of 60 nanogram. But let's say your instrument is about 200 square centimeter, you would tolerate up to 1,200 micrograms of protein, which is huge and can even be visually detected. So my point is, these two approaches are fighting each other, and we still do not have kind of a general vision of what protein detection must be here in Europe, and many other parts of the world are following the debate here in Europe. I think in about Asia, I think the US maybe as well, looking to Europe for that, and maybe other parts of the world as well. I think we still need to, here in Europe, make sure that we have a unified vision, which still I don't see where these people are heading, to be honest. I don't know if it brings a bit of a clear vision, but it's still something complicated here in Europe to make sure what needs to be done precisely, except that protein detection is the method to make sure your instruments are clean after the washer.
So, Thomas, I can hear a lot of people in the back of their mind saying, why focus on just protein? There are other things that are present in what we consider bioburden. Why is it that we would just want to detect protein? What is so special about it?
That's a very good question. Maybe a more straightforward one than I can really answer, because the proteins are a very good indicator of instrument cleanliness. And that is for, I would say, two main reasons. And the first one is that amongst all the soil that you find on an instrument that's been used in the OR, you have a lot of, let's say, blood, mucus, tissue, bone, and then microorganisms that would amount up to, let's say, a total bioburden. And the proteins among all of these soils are among the stickiest. So they will be able to stick onto surfaces very quickly because they are hydrophobic. They will stick to surface in a matter of minutes after they are deposited onto the instrument. And once the protein is stuck on an instrument, it is very difficult to clean it, really. And it's among the most difficult and the most challenging soil to remove from an instrument. And I think that is one of the main reasons why we focus on protein and not, for example, on polysaccharides or DNA or bacteria themselves. And then if you, at the end of the cleaning process, don't find any protein on your instrument, you can be fairly certain that there will not be anything else on your instrument. But if you detect protein, then you may have a cleaning problem. That's the first really argument, is that the proteins are one of the most difficult soil to remove from an instrument. The second point is that we can also say that, for example, the prions that we can find on the instruments, the prions are one of the most, let's say, important pathogens we can find on instruments, especially in neurosurgery. These prions are protein, they are hydrophobic, so they will also stick to surfaces of the instruments and be very difficult to clean. So by using proteins as an indicator of cleanliness, you also allow yourself to detect prions on your instruments and make sure that this level of prions that can be very pathogenic are detected with your methods. And even if we don't really know what's the minimal amount of prions needed to contaminate a patient, the minimal amount of prions on an instrument, the fact that you detect proteins after the washer, you make sure you keep that level as low as possible.
So, Thomas, following back up on the debate internationally between the different levels of protein that are acceptable, based on the surface of, or I guess the surface size of the instruments, that is a type of debate that we're very familiar with in the U.S., even though it's a different topic of debate. But the question always comes to who gets to make that decision ultimately, or who is at the table in terms of deciding what level is acceptable and how are we going to agree in a consensus to go forward and accept this one standard as opposed to another standard. So for that question, I guess today, who are the folks in these different countries who are having this conversation today, and what would you say is the best route to come to a scientific and just a concrete process agreement for the best way to do this in CSSDs?
I understand the question. That's actually a very good one, because if I go back to the two categories I mentioned earlier in the UK and in the EU, in the UK, for example, the guideline comes from the state. I mean, it's called HTM, it's Health Technical Memorandum, so it comes really from the government. And in, let's say, the EU, it's coming from the International ISO Standards Committee, which gather mostly industry experts. But the difficulty here is that the protein level detection that you need to achieve is really an expert opinion, because there is a lack of study that shows the problem that can be associated to a certain amount of protein. So naturally, when you don't have any data available, what everyone wants to do is to bring that level down to the least possible amount that you can find on instruments. And how can we do that today is by aligning to what we have in terms of detection technology. And that is where you find a very important position of the protein detection industry that wants to, as they have a new product with a better limit of detection, they will drive these standards to the lowest possible amount in terms of tolerable threshold. And I think that's what is happening in the ISO committees. I think there was also some influence in the HTM in the UK guidelines. So I guess it is quite difficult, because I would like to see more of the CSSD managers being involved in that discussion, which I don't see much, I have to say, in Europe. It's more of the industry trying to drive this limit down for probably very good reasons, although we cannot really justify it scientifically speaking, which may, on the side of CSSD managers, make it hard to accept that they would have to invest more time and money to make sure there is less and less protein, where the limit may not be as clear as it's set in the guidelines.
Yeah, so let's get into the technologies available then. We've been setting the stage where there's a lot of debate. There's obviously interest in acceptance in that it is good to monitor protein levels, and it is a helpful place in our overall quality management program. But how does it actually work today? What are the available technologies, RDN, CSSDs, to monitor protein after the washing cycle?
There are mainly two methods that exist today. I would classify them in two big categories. And the first one is what we call an ex situ method, is that you have to recover the protein from the instruments using a sampling method and then analyze it on the side of the instrument. So, for example, if you use a swab, you would have to recover the proteins from the instrument surface using the swab, and then using a chemistry that is able to detect the proteins on the side of the instruments, you would then try and detect these proteins by, for example, a color change, or you can even send it to a lab to have a quantification of the remaining proteins that you have picked up using your swab. And in these detection chemistries, you have, for example, ninhydrin, you have some aldehydes. These are chemical compounds that would react to the protein and make a color change that you can either see with your eyes. So that's the quick methods that you can use within your CSSD. In a couple of minutes, you get an answer, or you can even send it to the lab to analyze it. The main problem I see with these approaches is that when you have to pick up the proteins from the instruments, it means that you would have to make sure that you actually collect them, and you don't see proteins, because usually if you see it on your instruments, there is a major problem, and you wouldn't need to detect proteins to make sure that the instrument is clean, because you see it is not. If you use the swab, there is a major problem on knowing where to swab, then to access all these small, intricate geometry of the instruments themselves, and then to try and make sure that you've actually recovered the proteins that are on the surface. So I think there's a large sampling bias, potential sampling bias there that is not easily solved using these swabbing technologies. And on top of that, if you add the fact that in the washer disinfector, the thermal disinfection is kind of baking the protein onto these instruments, it's very, very hard. And I've made the experiments myself to try and pick up the protein, even if it was stained on the instrument. So I knew where to swab. It was very difficult to pick it up with the swabbing. So that's the first category, is to kind of try and recover the protein and analyze it on the side, called the ex situ method. And then there's another category, which is the in situ method. That is to trying to reveal the proteins directly on the surface of the instrument and then avoid the sampling and all its bias. So then trying to focus on the in situ is try and reveal directly on the instruments where the proteins are and in which quantity they are. So you can there is a couple of technologies out there that enables you, for example, using fluorescence to reveal directly and quantify on an instrument, although this technology may have some limitations using, the size of the instrument that you can actually analyze. But on the other side, you can really reveal proteins where the swab wouldn't be able to pick it up. For example, if you have surgical rasps for bones, it has kind of small, intricate features that is not possible to sample. So using this technology will also help you to see within these small features if there are any residues there.
Now, when we talk about lumen instruments and some other areas, I want to just call them nooks and crannies. There's lumens, but then there's instruments with nooks and crannies. Lumen instruments, we see enhanced visual inspection. And so like borescopes, for example, to be able to look inside. Would that type of technology be able to work in coinciding with the color change? And would you be able to capture all of that cleaning validation?
Sure, it would really depend on which technology you use. So some of the technology are not able to go into lumens, some others will. So for example, the swabbing, it will depend really on if your swab is able to penetrate inside the lumen to pick up the proteins. That is really like physical compatibility. But if you use another method that they recommend in the German guidelines is elution, so you use a liquid that has some properties to lift off proteins from the surface of the instruments to try and collect them. So that would also be compatible with the lumen instruments. And then, as you mentioned very well, there is also staining method that you can use, that you can completely immerse your instrument into staining chemistry that will mark where the proteins are present. And then if you couple it, as you mentioned, with the borescope technology, which is really growing in the market at the moment, would be a fantastic tool to really detect inside lumens, or even, let's say, crooks and crannies, where there is small features that you can really look at with your own eyes because they're not accessible. The borescope will enable you to visit these cavities and then make sure that what you see inside is actually protein or not. So if you put the borescope in without the staining technology, you would probably see oxidation, so rust. You would probably see some stains, but you would not be able to determine whether these stains actually contain protein or not. So you would have to kind of couple the borescope inspection with another technology. Staining is an example. You can also swab. You can also elute a liquid inside the lumen and then collect this and try and analyze. But this would be, of course, a very good way to go inside lumens and check whether these lumens still contain proteins after washing or if they don't.
Can you walk us through what a thorough protein detection process would look like in an active day-to-day sterile processing department? I mean, it sounds like this isn't something that you would necessarily be doing, to every single instrument. So obviously there's going to have to be some sort of sampling. So what would you recommend? What's the frequency of testing?
Sure. Yeah. It's actually complementary. The way I see it is that these techniques of protein detection, they are complementary to the validation of your washer disinfector that you do periodically. So as you say, it is not necessary or even, I think, possible in terms of human staff to do it on every instrument, every cycle. So as you say, you need to have an enlightened sampling plan of your instruments and see what instruments am I going to sample when? So in this regard, I think from my experience in the field, I would always recommend to try and select the sets that are difficult to clean. So I think about orthopedics, gynecology, that have the soils that are really difficult and to get rid of. And then on the other side, there's also some instruments that may be transported back from another facility, maybe have couple of hours to 24, maybe 48 hours transportation to the CSSD, during which the soil may be drying, and that also increases the cleaning challenge. So I would advise CSSD manager to select the sets that are the most challenging to clean, so that these would be the indicator sets. These are the ones you would want to focus on as the most difficult to clean. So challenge your process with these sets in particular. Then you would have to choose a sampling frequency, and what I think is realistic and what I propose is to test a basket of instruments going out of each washer every week. So that every week, for example, at the end of the week, you just take some basket out of the washer and you analyze all the instruments of these baskets. And why all of the instruments is because you would want to avoid picking some instruments in the baskets, because you would probably pick the easiest ones to clean without even yourself knowing it. It's just that if you must choose, you will probably choose the easiest one. So if you just take a basket randomly and you analyze all these instruments in the basket, you avoid this picking bias, I would call this. And then when you do analyze all these instruments from a basket for each washer every week, you record for each instrument how much protein you found. And I would also recommend to use a threshold based on some guidelines. There are several guidelines available, so I think the main point is to choose one and then know why you've chosen that one and stick to it. And then usually in the guidelines, you've got a threshold of proteins that will enable you to say if your instrument is, let's say, conform or not. And then you would have two values, so the amount of proteins you found and if the instrument is within that threshold or not. With all these data, every week you will generate a lot of data, because there would be, let's say, 25 instruments per basket in each washer every week. There'll be a lot of data. What I recommend to do is to go for a trend analysis for each washer, each type of instruments, and then every week you would have a lot of data to show that your cleaning process is under control. So really in this case, the protein detection method is really a way to make sure that your instruments are cleaned consistently throughout the time in each of the washer, and make sure that even when staff changes, when the detergent is changed, for example, or when the washer has been revalidated, you still consistently have the same cleaning quality as you had before. And in the audits that can be run by Joint Commission or any other bodies, you can then present this to the auditor and say, I've monitored my washers every week with the most challenging instruments and using this technology based on these guidelines. So you have a complete set of data that show that your cleaning process is running well.
Now, Thomas, if you're a regular listener, then you know that one of the passions of this show is to not only educate, but equip a user who happens to be listening to the episode, and they're sold. They understand now we've got to be doing this protein detection method. They agree with everything that you said, even down to the auditing aspect, to be able to demonstrate that you are actually monitoring and changing your practice if you're seeing some outliers here. But in terms of documenting user results, as you mentioned, it can get kind of complex fairly quickly. Are there any templates out there in the industry that folks can access and use to build these data sets in a way that's easy to keep track of, but then also easy to demonstrate to outsiders the progress and the results of these tests?
I'm not sure it's available widely in what we say, in open source anyway. I have seen a couple of CSSD managers who've kind of built up these systems themselves, building up a trend analysis software within Excel, for example. I think they would be willingly sharing these softwares if we ask them. But clearly, I guess one of the important thing of the industry in the future years is really to provide CSSD manager with these type of tools. At the moment, I'm not sure is really available. We as a company are working on that at the moment, so it's good that you asked the question. So it's really something we focus on to make it easy for CSSD manager to record their data and have an easy way to analyze them and take decision based on what they found out in terms of proteins. But at the moment, I have to say it's still there are still very few examples of these in the market, but I expect they will be coming in the next months and years.
Yeah, it's so much room for improvement in terms of emerging technology, and that's one of the things that we love to feature here on Beyond Clean. As we wrap the interview and we talk about technology, what would be some of the barriers to adopting this type of technology today?
Well, I see three of them. I would say the cost factor, the time factor, and the training of the staff. So if I take the first one, the cost factor it's clear that if you start sampling your instruments every week for every washer, it will come at a cost. And whatever technology you will use, it will still be a cost. It can be plus or minus, but at the end of the day, you would probably have to justify the expense to your management. So it's really down then to the CSSD manager to try and position this tool as a way to make sure that the cleaning process are fine, and then also to explain to the management that is as a great value, and making sure that these instruments that they deliver to the OR are actually clean and they can prove it consistently. So that's the first one, is really the cost factor. And I think the industry has a big role to play to provide the tools to the CSSD manager for each and every technology that is available out there to explain that, of course, it is a cost, but it also comes with benefits. The second one is the time factor. So I think people are doing it is the staff within the CSSD. They will be testing these instruments, and for them, it's one more thing to do. So it's also the role of the CSSD manager to make sure that people are dedicated to doing this. And the last factor is that these people are trained to do so. Because you often hear, I don't know how to do it properly, so I just do it my way. This is not good enough. So it's really then the role of the manager to make sure that the people are trained, that there are dedicated staff to do it, and they know how to proceed with the detection, to record the results, then so that the consistency of the data are ensured. So I think these are the three factors that may be a barrier. I know that when you bring the new technology to the staff, sometimes they're really enthusiastic about it and they do it right away. Sometimes they need to be explained the reason why we do it. I think these are the main hurdles that I see in the way of adopting these technologies.
Excellent. Thomas, you did a fantastic job on the show, and I can see that there's going to be another interview in your future here on Beyond Clean. Really shared your knowledge very concisely with our listeners, so thank you for coming on today.
Thanks very much for having me. As I said earlier, it's always a pleasure, so I will be delighted to come again on the show.
That was Dr. Thomas Vanzieleghem, Scientific Director at OneLIFE. And Mike, I think the quote that really stood out to me, although there's a lot of great information in this interview, was really the fact that he felt as though the same challenges here in the U.S. are also abroad, in the fact that we need more CSSD and SPD professionals involved in the development of the emerging technologies and also the development of the industry standards, recommendations, and guidelines. So it's kind of, in one way, disheartening on some level, but on the other level, it's great to know that we're not unique in that here in the United States. And I know there's a lot of push for changing that in the industry.
Yeah, I mean, that's one of the common themes that we keep coming back to in the show, and that's why, we're very quick to point out that, Beyond Clean is downloaded in 125 countries. It's because these are global problems. This is not unique to any one country or one border. This is something that's going on everywhere. And so anything that we can get that opens up those lines of communication and allows us to have these global conversations, only good things are going to come out of it.
I couldn't agree more. That is going to do it for this week's show. As a reminder, you can help support us by subscribing to Beyond Clean on iTunes, Stitcher, Google Play, or Spotify. Simply search for Beyond Clean Podcast. We'd appreciate a rating and a review because your feedback is important to the show. And if you have any topics that you'd like us to cover on a future episode, or if you'd like to share a picture anonymously on our Instagram page, just send an email to info@beyondclean.net. On behalf of Hank, Mike, and myself, thank you for listening to another edition of Beyond Clean.